Concrete Fundamental Part 8, Resistance to Freezing and Thawing. Question: how is concrete made resistant to cycles of freezing and thawing? Answer: air is entrained in concrete to increase its resistance to disintegration when exposed. 2 cycles of freezing and thawing in a critically saturated condition, and 2. Minimize the scaling that results from applications of chemicals for ice. Removal ACI to 112.3 R. Entrained air bubbles of diameters larger than 3 microns provide resistance to damage caused by freezing and thawing. Bubbles should be distributed in the cement paste at a spacing not greater than 0.2 millimeters, achieved by the use of air-entraining admixtures or air-entraining. Hydraulic cement ACI to 101.2 R. These closely spaced air bubbles provide relief from the pressure built up by the freezing of water in the capillary cavities in the cement paste, and thus minimize damage to the hardened paste. The number of freezing and thawing cycles that can be resisted by air-entrained concrete is improved several 100% compared with concrete not containing entrained air. On freezing, water expands in volume by about 9%. Concrete rarely contains more than 10% freezable water by volume, resulting in approximately a 1% expansion. An air content of 9% by volume of the mortar fraction is usually sufficient to protect the concrete. Question: are the limits on air content that have been commonly used 3 to 7% by volume of concrete considered satisfactory for nearly all purposes? Answer: in most air-entrained concrete, values between these limits based on total concrete volume have been the aim. ACI to 111.1 considers different exposure conditions and makes some allowance for different sizes of coarse aggregate, requiring higher percentages of air, where the mortar portion of the mixture is higher. To keep within the desired range, reliance has been chiefly on adjusting the amount of air-entraining admixture to achieve the generally desired bubble spacing of 0.2 millimeters, using an air-entraining admixture meeting the requirements of ASTMC to 160. The dosage should be sufficient to produce 9% air in the mortar fraction of the concrete. The portion that would pass through a 4.75 millimeters no for sieve